everybody. I'm Sébastien Deleuze. I have been a Spring Framework committer for 12 years now. I have recently joined the Spring AI team, so I'm currently splitting my time between Spring Framework and Spring AI projects. And I'm going to talk today about a topic that has occupied most of my previous year, working with the wider Spring team on introducing null-safety in the whole Spring portfolio. And we are going to see how you can benefit of that in your Spring Boot 4 applications. So, I mean, you already know null pointer exception that come basically Friday afternoon on production, and then you need to redeploy stuff. And yeah, what we want to do is not to, basically, null pointer exception still exists, but we want to handle that before shipping our application on production. And we are going to see that it's much more involved and profound than just removing null pointer exception. So this is going to be the topic for today. So are we fixing the billion-dollar mistake, which is basically the qualifier that is used by the null inventor on C side? Yes, we are, and we are going to fix it with Spring Boot 4 and JSpecify. So JSpecify, it's a community effort that has been performed by various companies and organizations like Google, JetBrains, Broadcom via Spring, and many others. And basically, we have tried to come together in order to standardize annotations to express null safety, but also the scope could be a bit bigger later. The goal is to provide like some annotations that are not tied to a specific tool to express that, to provide capabilities that allow to get next-level static analysis in your IDE, in your build tools. And this is what we are going to use today. JSpecify, it's not just for annotations, it's also full documentation, comprehensive documentation that basically explain all the nuances of nullability, and believe me, there is a lot of nuances, especially when we are talking about generic types, nullability, for example. Moritz, I guess you remember this very long task on Spring Boot 4. It's also specifications. This one is a bit more involved, so unless you are a compiler engineer, I don't really advise you to read that one, but this is one that is useful for tooling vendors. So basically, VS Code developers, the people that develop the VS Code IDE or IntelliJ IDE or NullAway or other kind of tools, they are using that as the source of truth to implement the same behavior. That way, whatever tool or IDE you are using, you are expected to have the same behavior. You may wonder, Sébastien, in 2017, you said that you were introducing null safety annotation in Spring Framework 5, so what's new? That's true. We have been introducing that pretty early. It was inspired by Kotlin, which was providing that on Kotlin side, and we have made a first step to introduce null safety on Java side. But those Spring Framework annotations are now deprecated in favor of JSpecify annotation. So if you have a Spring Boot 4, Spring Framework 7 project, you will see that those null safety annotations that are in the org.springframework.lang package, they are now deprecated since 7.0, and you are advised to use JSpecify instead. If you are using those annotations, the best way to migrate is not to use your agent to do stuff with Cloud Code or whatever. It's just to use Open Rewrite or Tanzu Application Advisor to migrate automatically, because the rules of conversion are pretty simple. You are just migrating from Spring Framework nullable to the JSpecify one with some nuances. So just applying those recipes is likely the most obvious way to do that, and that's pretty simple. Okay, so what changed? What are the news? So we are coming from Spring Boot 3 with Spring Null Safety Annotation, with mainly two projects annotated, Spring Framework, Spring Data. We were not using an automated tool to check everything was consistent. So to be totally transparent, it was Jürgen and me checking warnings in IntelliJ IDE time to time to fix stuff. It was not super deterministic, but at that time, it was like a first step, and it was already good enough. We also got a lot of feedback from the Kotlin community, because basically when you get null safety wrong, nullability wrong, Kotlin developers can't use your API because they can't provide, for example, a null parameter. So we got a lot of feedback on that, and the Kotlin community has been contributing a lot to the quality of the nullability annotation that we have now for the Java developers as well. There has been some translation from the older Spring Framework annotation to Kotlin, but it required an explicit flag. Now, as of Kotlin 2.1, the translation from JSpecify to Kotlin null-safety is automatic. Nothing is needed, automatically handled by the Kotlin compiler. We have now proper specification, canonical dependency, because I think there is at least 5 different GSR 305 dependencies that are flying around Maven Central. So here we have a single, well-identified JSpecify dependency, usable outside of Spring, and it was not usable outside of Spring, except if you are using directly GSR 305, and there was no handling of generic type nullability. What is new is that basically the Spring team, and I thank all my colleagues for this very long task, the whole Spring portfolio is now providing full null-safe APIs. I'm going to list all the projects. It's going to be long, but let's do it. So in addition to Framework and Data, who just migrated from Spring Framework to JSpecify annotation, we have now boot security, AI, batch, Kafka, integration, GraphQL, web services, MQP, Shell, 8OS, modulated cloud, and even Micrometer and Reactor are providing null-safe annotation with JSpecify. It has been long to introduce that, but now that it's introduced, we are able to move faster and in a most safe way for the future evolution. And we get all the benefits. All those projects are just not adding annotation and basically praying for them to be okay. Every project has introduced NullAway checks. So as soon as we have inconsistencies, Spring project build is broken and we need to fix it. We have out-of-the-box Kotlin support, proper specification, and generic type nullability. So it's really the scope and the quality of those null-safety annotation that have dramatically improved. So in practice, if you are using Spring Boot 4 and you go to the Java doc, you will see on almost every packages a null-marked annotation on each package. We have decided to null-mark every package. That means that in this package, the default is non-null. So if there is no other annotation, default is non-null. And then you only specify explicitly at nullable, because we have, I'm not sure about the stats, but something like 5% of the type usage are nullable, and the rest are non-null. So to limit the noise, basically we focus on marking explicitly the unusual case. So in this package, when you see this kind of method definition, where basically no JSpecify notation, that means that the related parameters and return values are non-null. You don't need to check null return values. You can't provide null parameters. You know that for sure, and it's checked and validated and everything. And when we have something that is nullable, either in terms of return value, so you need to check the return type, or a parameter where you can potentially pass null as a parameter, this is explicitly mentioned by this at nullable annotation, which is a JSpecify annotation, and this is true for all the Spring portfolio. So what are the benefits for Java developers? And by benefits, I mean you don't have to do anything except just consuming using Spring Boot 4, okay? After that, we will see more involved steps. So if you are using an IDE that supports JSpecify nullability annotation, you have support out of the box in IntelliJ IDE, you have support via plugins in VS Code, you will get this kind of warnings where if you are trying to do something that is not null-safe, like here, get web application type can be potentially return nullable values, and you need to check that before calling a method on it. You will get this kind of warnings with autofix, and so you get that information even before running your Maven or Gradle build. Same if you try to pass null parameter to something that is not annotated with @nullable, the IDE will say you, hey, it looks like you are doing something not really authorized, and you get the information ahead of time. But it's much more than just avoiding null pointer exception. When we have introduced nullability in all Spring projects, we did that recently in Spring AI, it has a profound impact. Nullable is a zero-cost abstraction allowing to express the potential absence of value. It was kind of implicit before, and now the fact that it's explicit, it allows us to basically code with more confidence. Kotlin developers know what I mean, but that's also true for Java side. And for example, on Spring AI, the fact that we have added explicit nullability and that we have made everything explicit about this is mandatory, this is optional, has led to a big refactoring of the option management for Spring I models, and you will see that in Spring I 2.0. So it's much more than basically just avoiding null pointer exception. Let's talk about optional. So you may wonder, why don't use optional? I mean, it's provided by the JDK. It's designed to express the potential absence of value. And optional, sadly, is not usable for a lot of use cases. So it's not a general purpose solution for what you want to try to do. Because we don't have yet Project Valhalla, so there is runtime overheads. But the most important thing, do you think that Spring, JDK, and other popular projects are going to modify all their API signatures to replace T by optional of T? No, it will never happen. We can break all those APIs that are here forever, or at least for 20 years. It's impossible. So we can't use it. And also, it's not intended for use as parameter or fields. It's not a personal opinion. This is stated by optional Java doc. For various reasons, you can have a deeper look. And it just increases the complexity of code because you are putting wrappers everywhere, etc. So yeah, I'm not a good friend with optional. I think when you are expressing explicitly nullability, so the absence of value or not explicitly, a lot of use cases can be solved without optional. Benefits for Kotlin developers. So if you are Kotlin developers or if you are a Java library developer that you are targeting by nature, basically Kotlin developers, this is the Spring API that is visible from Kotlin in Spring Boot 3. As a Kotlin developer, I see a lot of exclamation mark at the type system. Exclamation mark means platform type, mean unspecified null-safety. So basically, Kotlin managed natively null-safety for its own API, but for the API that are coming from Java, Kotlin is not sure if that will be nullable or not, so it will be lenient, but at the same time, you are at risk to get null pointer exception. And so, as a Kotlin developer, when I see that, it feels like Java compatibility mode. It does not feel very idiomatic. And when I'm using the same API from Spring Boot 4, it's like Spring Boot 4 was developed natively in Kotlin. I get everything specified explicitly, including on generic types. Nothing specified means basically it's non-nullable. This is the default. And when something is nullable, we have this question mark mechanism. So basically, Kotlin compiler is translating automatically at nullable annotation to question mark thing, and the rest is non-null. And it looks like Kotlin idiomatic code. So that's a big change for Kotlin developers, I think. When there is nullability mismatch, of course, like with Kotlin code, it will trigger some error in the IDE. You get also basically compiler errors if you are not basically complying with the nullability, and everything is safe, and you are not at risk anymore to have null pointer exception on production if you are using Kotlin and Spring Boot 4. So now if you want, we have described until now what you can do just by consuming Spring Boot 4. You have not done specifically, except that you have upgraded from Spring Boot 3 to Spring Boot 4. But what we did for the Spring project, introducing null-safety, introducing NullAway, etc., you can do it for your own project if you want. It's totally optional. I'm not saying you need to do that on every project. There is a lot of added value doing that, depending on the context, but I'm going to explain how you can make your project null-safe, because you can't really be sure that you are not at risk to get null pointer exception in production. We are covering the library code on Spring side, but on your side, your application is at risk to produce null pointer exception. So, very basic step. So the first step, step 0, is upgrading to Spring Boot 4, okay? Mandatory. Then, read JSpecify documentation. That sounds like a very basic advice, but in the age of Gen AI and everything is going so fast, please take the time to read the documentation. The user guide is really designed for application developers, and understanding the semantics, the nuances, especially regarding to generic types, array elements, and various things, it's worth your time. So take your time, read that carefully, it will be useful. Second step is to have the right mental model. Naively, you may think it's just nullable, non-nullable, but it's not the case. Java code has unspecified nullability. And basically, this is similar to Kotlin platform type. If you have some code that is not annotated with JSpecify, you don't know what is the nullability. And you will potentially mix that with some code that is null-safe, for example, the Spring one. So regular Java, unspecified nullability. Everything is implicit. You have to read the Java doc or read the implementation, or I'm not sure what you need to do. Java plus JSpecify, you are switching in a mode where the nullability is explicit, and a type usage is either nullable, can include null, or non-null, never include null. Okay. Then you need to add the JSpecify dependency. So there is a canonical dependency, which is this org.jspecify group ID, JSpecify artifact ID, and 1.0.0. Super simple. You need to define the scope of where you are going to introduce null-safety, because if you have hundreds of thousands classes project and you want to introduce null-safety one shot, it's going to be difficult. So I really advise to start small, focus maybe on one single package initially, or maybe one module if that's bigger, and basically only check that the nullness declaration are consistent within this very same package, and then you are going to extend the scope gradually, because otherwise it's going to be difficult. So when you have identified a nice package to start with, you just add a package info, or edit if there is already one, and basically you are going to add this null-marked annotation, which says, within this package, everything is non-null by default, and every nullable use case will be mentioned via @nullable. Okay? This is not supporting subpackage. So if I have org.example.foo subpackage, I need to create another package info and annotate it, like it's regular Java way of handling things, but it's not transitive. So annotating one package null mark is pretty easy. Now it's going to be a bit more challenging, because you need to add carefully nullable where that's relevant. So here, for example, I have added nullable on the return type, because here, this method can potentially return null. Simple example, but when you have like a huge number of classes, you need to infer it based on the Java docs, the implementation, and you have to start somewhere, and then you will be able to use some tooling that will report errors and then take it from there. Before going to see some ways of basically doing that in a more automated fashion, a few tips and tricks. So JSpecify annotation are usually not enough to avoid too many false positives. We need to express additional semantics. This is why Spring Framework has introduced this contract annotation, which is similar to JetBrains or GSR 3051. And here, we want to express additional semantics that JSpecify can't yet express. By the way, we are working on JSpecify side to standardize this kind of contract, but it's not yet ready. So here, for example, I want to express that when the Boolean expression is false, this method will throw an exception, and basically the code flow will not continue. And this is useful for static analysis of the code, because here on the usage side, after calling assert.state, foo is different of null, I can be sure that basically foo will be different of null, because if not, an exception will be thrown, and the foo.something line will be never reached. So this is why, without this contract annotation, I would have some false positive of NullAway saying, oh, foo can be null, it's dangerous. But here, with this additional contract information, NullAway, the analysis of the code, will basically be able to say, OK, I know that when basically I'm reaching foo.something, foo is not null. So very complementary. To give you an idea, this is the most frequent contracts that Spring Framework codebase is using. Of course, in your project that will be different, but it's interesting to see the patterns. You see the patterns where basically when a parameter is null, something is returned false, or this is again used by NullAway to basically refine the code path analysis. You have some use case where basically we are throwing exception depending on the parameter values. We have also what we call polynull. So polynull is basically the nullability of the return value depends on the nullability of the input parameter. And this is what specialists call polynull. And other kind of use case, but this is the popular use case we have in Spring Framework, and maybe that can provide you inspiration for the kind of use case you may have to manage for your code base. I think we are using that a lot for the utility classes, assertions, stuff like that Spring is doing. So maybe useful. Second hint, you can express flexible nullability at class level. So I won't go into the detail of the nullability of generic type parameter at class level. It's pretty complex, but here, basically, I want to express the fact that T, that is defined at the class level, can be sometimes nullable, can be sometimes non-nullable. And the differentiation will be done when I will declare a transaction callback. So if I declare transaction callback at nullable object, that means that the return value will be nullable. If I declare something like transaction callback object in a null mark code, that means that this is implicit at non-null, so the return value will be non-null. And so the way to express that on declaration side is basically T extend at nullable object. You can read JSpecify documentation to understand why we have to use this kind of syntax, but yeah, this is the best way we have found to express that. And if the declaration was transaction callback at nullable of T, that would mean that T is always nullable. Okay, so here we want to be flexible. And this is only possible here because there is a direct T at class level has the same nullability than T at the return value of the method. Sometimes it's not the case. So this kind of flexible nullability at class level is not always possible, but sometimes it is. Arrays and varargs. So we are going to learn a bit of more syntax. So basically, JSpecify nullable annotation is basically only targeting type use. And those type use annotation have specific syntax to be able to differentiate if the annotation annotates the element type or the array itself. And so with JSpecify, when you want to say that the individual elements of the array are nullable but not the array itself, you are going to use this at nullable object square brackets syntax. When you want to express that basically elements are not nullable, but the array itself could be nullable, you are using this object at nullable square brackets. You can basically think that, yeah, you are going to annotate basically the element where you want to express the nullability. And if you want to express that both elements and array can be nullable, you would put at nullable object, at nullable square brackets, and you are fine. Could be a bit weird initially, but there is more weird. There is that. So this is not JSpecify fault. This is a Java specification for, again, annotation that are only targeting type use. And so the Java specification, I think it's supported as Java 8, so pretty old, but hardly used. If you want to annotate basically an inner type or a fully qualified type, you need to put the annotation after the last dot. So if you put at nullable cache dot value wrapper, you will have a compiler error, and same for the fully qualified Java validation validator. So a bit weird, not that common, but this is Java specification, so JSpecify is just following that. So just be aware. Okay, now we have just annotated our code base, but we have checked nothing. So basically, there could be plenty of errors. We could annotate the wrong thing. It's not super. Yeah, it's not very good. So we are going to introduce build check with NullAway. NullAway is going to allow us to perform build type checks to check the consistency and the correctness of the nullability annotations. So you need to use a recent JDK. So the updated guidelines are, if you are using JDK 17, you need to use JDK 17.0.19+, which will be released next week. So almost good timing. Before, you had no option except using a more recent JDK. So it's a good thing that this support has been backported to Java 17. So you need to use this recent version, and you need to use a Java-C argument that is specified here. Same for JDK 21. This one is already available, so 21.0.8 or more recent, with the very same Java-C argument. And JDK 25, no argument is needed. It's supporting everything by default. And what you can do, and this is what we have decided to do in the Spring portfolio, you can totally use a more recent JDK to compile your application and specify -- release 17 if you want to have a 17 baseline. And it's very safe because we are doing that for Spring Framework and Spring Boot and Spring Data and all of our projects. So my recommendation would be to basically decouple basically the version of the JDK that is used, and you use the more recent LTS 25, and use -- release something which is basically your baseline. So let's see the detail of the configuration. For Gradle, we are going to, NullAway is an extension for error-prone. Error-prone is basically static analysis tool maintained by Google. And so we are going to declare this error-prone Gradle plugin. We specify that we are using a recent Java 25 version. And in addition to the JSpecify dependency, we are adding with error-prone configuration, error-prone core, and NullAway dependencies, which are annotation processors. And we are going to configure NullAway in order to first disable all the other checks from error-prone, because error-prone is doing much more other things than NullAway. And so here, on my side, I prefer to focus only on NullAway checks to not have additional noise and concern. Feel free to enable that after, but initially, I would advise to focus on just NullAway. By default, NullAway is basically generating warnings. I prefer to configure errors, a bit like Kotlin compiler behavior. We are using JSpecify, then we enable the JSpecify mode. It may become the default a bit later, but right now it's a flag that we enable explicitly. And the last option is pretty important. We say that we want to only perform checks on null-marked scope. And this one is super important to introduce gradually NullAway checks, because if you are just annotating one package with null-marked, NullAway will only check this unique package. And then you can expand gradually the scope. So this option is really cool. And option release 17 if you want to specify the baseline. Maven configuration is going to be a bit more verbose. So we configure the same 25 Java version, same JSpecify dependency, and we are going to do a bit of advanced Maven compiler plugin configuration. Mark, I see your eyes. I see you are crying thinking about Spring Data Maven configuration, but yeah, let's see. So you need to configure the fork is enabled, and we are going to configure annotation processor path and compiler args. Annotation processor path, very similar to Gradle, the two same annotation processors. We are fine. Now brace yourself. Yeah. So, compiler args. So, we have to add explicitly a few exports that are required for NullAway to have access to special JDK compiler capabilities. By the way, Gradle is doing the same. It's just that it is hidden. But here, it's not hidden because there is no specific plugin. That means that if somebody in the room wants to develop a NullAway plugin for Maven, be my guest, and please remove that madness from our configuration. But right now, we have to specify it explicitly. Just copy and paste, put that in a profile, and forget about it. And otherwise, you are going to specify the various arguments to disable or check, turn warnings to errors, enable JSpecify mode, and only enable .mark. Those args in this line with disable checks, they need to be on the same line. You can't use, don't ask me why, Maven craziness. So yeah, you need to copy that, don't touch it, and it will be fine. Thanks. Okay, if you want to have a deeper look, I have created this JSpecify NullAway demo repository where you can check. There is a Maven branch, main is with Gradle, and you can test it with a sample project. It will be easier to start. Okay, now the most fun part of the talk. So it took a lot of time to the Spring team to add nullability annotations. Remember, it was last year, not in 2026. And also, I mean, at some point, we were the first one to do this kind of thing at that scope. I mean, Google has also introduced nullability annotation on big project, but I think we are the bigger. So basically, us poor humans had to spend a lot of time, to annotate the code, see NullAway errors, fixing stuff, and doing some kind of work like that. The good news is that we have recently learned that coding agent can make codebase null-safe automatically. Of course, as a human, you are responsible for your code. You need to review and own what you produce, even with crazy tools like that. But still, it's possible, but you need to teach them how. And I'm going to share some secret recipes with you today. And we have been able to successfully and especially Joe from the security team has been able to apply that using Cursor and some anthropic models. So I think he used Sonnet, but Opus should be even better. With other models, like I tried with Gemini, does not work. So really, it really depends on the models, the version, how many people are using Cloud Code while you are running that. So it's not deterministic, right? But it should be doable. So let's see how we do that. We need to do a lot of preparation. If you just ask, add JSpecify annotation to my project, nope, it won't work. So we are going to do a bit of preparation by creating some skills. You can also potentially use the plan mode of your agent to do that, but I prefer to use skills because they are reusable multiple times and you can refine them. So we are going to prompt creation of skills that should add automatically JSpecify support. So the first one I advise to do is something like, so this is my prompts, okay? Create an agent skill named JSpecify user guide from the URL of the JSpecify user documentation that will define rules useful to introduce JSpecify annotations to a Java project not yet annotated. So it should create the related skill. Second one, do the same thing basically, but with the Spring Framework null-safety documentation that I have carefully crafted, and that provides additional rules. Some of them are specific to the Spring project, but it's pretty complementary, and since we want to be mindful of our context, focus on the rule not yet identified in JSpecify user guide, so that should be a superset, okay? Then, the big one, and this is the one that is basically going to suck my brain and basically reuse that knowledge for your project, because basically I spent hundreds of hours adding nullability annotation on Spring Framework. Moritz did the same for Spring Boot. Mark did the same for Spring Data. And so basically, you can reuse all this effort by learning some rules. And so basically, my prompt is, create an agent skills based on the detailed analysis of the JSpecify nullability and add contract annotation in URL of the GitHub repository of Spring. Focus on the Spring Core module, because if you are doing that on all modules, basically that will be too big, so I really advise you to go module after module, and Spring Core is the most important one. And identify implementation pattern and best practices. The goal is to identify the various ways to infer those annotations, especially at nullable ones, based on the implementation of Javadoc. Focus on rules not yet identified in previous skills. So it's really this one that is going to be the most useful, because you are going to learn about all the nuances, the subtleties that are even not specified, and you can basically refine using other modules. So basically, do the same, refine those rules, analyzing Spring Web module. I know Joe has been applying that on Spring Security, so basically, even a new project, if you have annotated one module, you can say, okay, learn my own rules that may be not the same as Spring ones, and then you are adding a complementary skills. And then, last one, create an agent skills named NullAway configure by analyzing the repository I was showing just before to understand how to configure NullAway in Gradle, Kotlin, or Maven builds. So here, you are finished to create your rules, to learn, to do your plan modes, and you are ready to do the effective work on your project. So you open your project, you open an agent, Cloud Code or whatever. You start by configure NullAway in my project using NullAway configure skills. Should be good. And then, the most important part of the work, add JSpecify and contract annotation to package something, or could be a whole module, to make it null-safe using the agent skills prefix with JSpecify, so all the one we have been creating previously. Run the build, analyze NullAway error messages, fix related errors, and repeat until there is no error. And basically, add potential new rules discovered to an agent skill named JSpecify agentic loop analysis. So basically, while the agentic loop is going to run NullAway, see errors, fix them, okay, I have 2 less errors, I need to fix 5 other ones, etc. The agent will be able to discover new rules automatically and converge gradually to basically discover those new rules and have 0 error. And again, Joe Granja has been applying that successfully to add nullability automatically, with him as a human checking that everything is relevant, of course, in some Spring Security modules, using the work that has been done on other modules and Spring Framework, etc. So I think that's pretty cool, because it was the main drawback of this null-safety effort, that it required initially quite a lot of work to annotate a code base, because the rules are pretty nuanced, and it was a bit challenging. And now, with an agentic loop, NullAway, and some careful skills that you can craft like that, you can automate that and just burn a few tokens and yeah. We can do also detection of nullness at runtime. So be aware that I have introduced a nullness enum class in the org.springframework.core, which basically models the free state I was mentioning at the beginning, unspecified for unannotated code, nullable, and non-null. And basically, you have a few methods like, give me the nullness for this method return type, or this parameter, or this field. And that's basically a kind of reflective API that will allow you to discover that at runtime, and it automatically takes into account JSpecify, Kotlin APIs, and reflection, and also add nullable annotations. And in practice, we are using that, for example, for the request param support. Basically, when no nullability is expressed, by default, a request param is mandatory. So if you are not specifying it, an exception is thrown. But if you are annotating with @nullable, basically it will be null, and it will let you handle that. And we are using this nullness class internally to do it, but you can also use nullness on your own code. If you have some features where to generate some forms or whatever, you need to discover at runtime the nullability of your annotated API with JSpecify, you can do that with that. Okay, and the last part is the evolution of the Java platform. So JSpecify is cool, but it's still a bunch of annotation with specification that are created pragmatically by some enterprise. What about getting Java platform supporting nullability like Kotlin does? The good news is that there is ongoing effort for that. The first related effort is lazy constants. Lazy constants are a bit like final fields, but basically, they provide a more flexible behavior for the initialization. Like, you can initialize lazy constants after the constructor. Just you can initialize it one time, and the content will not be null. And so, basically, you can get the same benefits, performance optimization, than final fields, but with a much more flexible approach. And for nullability, that's very important to be able to express this. This thing is going to be initialized a bit later, but then just one time it will be non-null, and so this is going to be supported by the JDK. But the most exciting feature is, of course, Project Valhalla. So Project Valhalla, we are talking about it for 15 years, very long time. I'm not sure how many years, but very long time. The most popular feature is value classes. To introduce objects that lack identity, and you can do related optimization, and Kotlin has that, for example. But in recent version of Project Valhalla roadmap, you can see that the second most important feature mentioned is null checking at both compile time and runtime to manage the flow of null references through programs. That's pretty exciting. This is basically partially similar of what we are going to do with JSpecify. But of course, if you are supporting that at JDK level, you can implement such support directly in Java-C. You can do optimized check at runtime. It will be much more powerful. And while JSpecify does not provide efficiency runtime benefits, this effort can do it, because if a field is non-null, you need one less bit to basically store it. So you can get memory alignment, everything is optimized, and this is why they are introducing it as part of Valhalla. In order to get full benefits of value classes in terms of performance, you need to be sure that the related field is non-null to get everything aligned and optimized. And it's getting concrete. Like you can see in this Project Valhalla PR, that basically they are modifying the JDK APIs. They are adding this kind of exclamation mark to say this parameter is non-null. And so since that's expressed at Java platform level, you can remove the objects that require non-null. You don't have to execute this code. It will be more efficient. It will be checked both at compile time and at runtime. But at runtime, it will be like super optimized intrinsics that will be like super efficient. And this is also less noise in your API. My hope is that they provide a way, like at nullmark from JSpecify, to define the defaults, because again, 5% of your use cases are nullable most of the time, and so if we need to annotate everything with exclamation mark, there will be a lot of exclamation mark in your code, right? So it's a matter of trade-off. If they introduce a default, basically you need to be context aware to know if you are in a package, a module, or something that is basically in non-null by default mode. Here, Kotlin, it's easier because they choose the right default, but many years after. So let's see. But it's exciting, and you can basically provide direct matching between JSpecify annotation, null mark code, or non-null to this kind of thing. So basically, this will take many years to come as in your Java version. It will require to bump the baseline to, I'm not sure, Java 33. So quite aggressive baseline. So I think it's a safe bet to invest into JSpecify, clarify the semantics of your code, and then when that will be ready, I'm pretty sure there will be some kind of annotation processor that will translate JSpecify annotations to this kind of bytecode level JIT thing, and then everything is fine. And also, you can see that, for example, the nullability of generic types is not supported, etc. So we expect that JSpecify will be much more complete than this support, but will provide additional runtime benefits and a dedicated syntax. So thank you for your attention. I can answer to a few questions, and after the talk, you can come to get this. I think I look older on this picture, or maybe that's myself, but yeah, not sure. But you can come, and I have a few cards if you want to get them. Thank you. Is there any question, or yeah?
If we're using error-prone for extra functionality, I understand why we use that, but if IDEs are checking nullability annotations, do we still need error-prone, or this was just an example of how to set up it properly if we need extra features?
Yeah, so if I understand right your question, you are already using error-prone, but your IDE is going to provide feedbacks on nullability. So do you need to use NullAway or check like that in addition?
The question is if you're not using error-prone.
Oh, if you're not using error-prone.
Do you need it?
Yeah, if you are not using error-prone, I mean, NullAway extension of error-prone. I don't really care about other checks from error-prone. You can use them or not. I have no opinion on that. But I have seen the difference of quality between I'm checking warnings into my IDE time to times, and then be sure that everybody using Kotlin was broken and there was a lot of inconsistencies. So really, if you are just building an application, you can potentially annotate a few nullable use cases here and there. If you are publishing a library or even within your company, you should really check with NullAway the level of quality. It's not the same at all. So yeah, I'm not really pushing everybody to basically, it's quite a lot, it's still some work. Maybe AI will make it easier, but introducing null-safety and checking everything in your project is quite some work, so you can just consume it. But if you will begin to annotate, I would really advise to do the full NullAway stuff. And like I said, maybe a trade-off is you are using NullAway with error-prone, but just on specific packages. It will, by default, with the configuration I shared, only check packages annotated with null marks. So maybe begin by a more specific scope, but yeah, check with NullAway and error-prone. That's the same. Yeah.
I'm curious regarding some false positives that we can have with NullAway, and what do you think is possible to put separation to the specific case with this case?
Yeah, so about the false positives that are detected by NullAway, how can we handle that? Because there is suppress warning NullAway, which is a bit generic. So there is a specific variant which is for lazy initialization, which is suppress warning nullaway.init, which is able to specify that. Maybe more use case will be identified, but we are, within the JSpecify group, we have two additional refinements we are working on, potentially defining a standardized suppress warning nullness or something like that, and we are discussing potential way to express some variants for the reason why we have to do this kind of suppress warnings, and also standardizing contracts, like I was mentioning. So maybe via this kind of ongoing standardization effort, we could identify some specific way to identify more specific reason for basically, to basically not know why we have to define, to specify suppress warnings. In the meantime, NullAway itself is evolving. Like currently, there is a big effort to introduce very consistent nullability for all GK APIs, and maybe more advanced contract and various other bug fixes that are basically reducing the need for suppress warning NullAway. Like, I remember when we first introduced that in Spring Framework, we had a lot of suppress warning NullAway because sometimes NullAway is not clever enough to analyze the code flow of your code. And I think we have removed half of them. And basically, the NullAway author and the JSpecify working group, they continue to refine some use case to reduce that need. So I think we just need to get a bit more evolution on that and get NullAway more clever. And yeah, okay.
What's your recommendation regarding JSpecify dependency? Just because this is a library, you have to add it to your build.
Yeah.
So, what is the best strategy to add it explicitly or using as a dependency from framework?
Yeah, so how should you manage this JSpecify dependency? So I don't really have a strong opinion of should it be defined explicitly in your project or come through the transitive dependency on Spring. But the important point is that I think it should be a transitive dependency of, for example, your library. So in Spring Framework, for example, this is not a compile or optional dependency. This is like a regular dependency that will be a transitive dependency. So if you are using Spring Boot, Spring Framework, whatever, you will have basically JSpecify already as your dependencies because it's not optional, it's not compile only, it's like regular implementation or API, I don't remember, but dependency that will be used transitively by your project. So you don't need to add it explicitly, but if you are not using Spring, you should add JSpecify as a dependency, and I recommend to make it like a transitive dependency. One of the reasons is basically if you are just using an optional dependency, or compile only, when people are going to watch your source code, there will be red annotations everywhere because JSpecify is not in the class path. When you are doing some runtime check with nullness thing or via reflection, I think it's the best practice. I mean, you can deal with that with bytecode manipulation, etc., to detect it, but I think it's just a good practice to consider JSpecify annotations as part of your API. I mean, it's going to qualify the nullability of the types, so it makes sense to use it as a transitive dependency that you don't have to hide. Technically you can, but I would advise to make that explicit. Okay, thank you, and feel free to come to discuss after the talk. Cheers.